Friends, this video is about solidifying or gelling agents used in tissue culture. Gelling agents are the main media in tissue culture. So, where it is used, what is the requirement of it, we shall discuss one by one. Solidifying agents are used in micropropagation because they provide ideal supportive conditions for plantlet through, although the overall expenditure of the in vitro production increases as these are expensive products. Agar and phytogel are the most commonly used solidifying agents in tissue culture. You need to remember the most commonly used solidifying agents are agar and phytogel. Agar is extracted from red algae, mainly from the species Giladium amense lamorox, and consists of a complex mixture of polysaccharides, especially agarose and agaropectin. Agar is made up of agarose and agaropectins. Phytogel is a polysaccharide produced by the bacterium Spangomonas elodie, that is Pseudomonas elodie, and is composed of molecules of ketogluconorate, rhamnose, and sallabiose. Substitution of agar with other polysaccharides like phytogel improves the production of shoots and reduces the cost of micropropagation by up to 90%. Therefore, the use of alternating solidifying agents become important in order to increase the production of plants in vitro. Activated charcoal is another material used in the tissue culture. This is a coal powder that has been finely milled in order to increase the adsorption area of the particles. Its addition to the culture media promotes darkening of the medium. It participates in the adsorption of substances released by the medium, such as impurities in agar, growth regulators, organic compounds, or phenols released by the damaged tissue in vitro. Thus, activated charcoal is beneficial in the development of plants in vitro. Most commonly used gelling agents are gelatin, agar-agar, and agarose. Gelatin was first discovered in 1682 by Denis Papin, a French biologist. Agar-agar was first subjected to chemical analysis in 1859 by the French chemist Anselme Payen, who had obtained agar from the marine algae Giladium corium. Beginning in the late 19th century, agar began to be used heavily as a solid medium for growing various microbes. Agarose is one more gelling agent, which is the pure form or one of the component of agar. Agar is not much utilized for tissue culture purpose, but it is used in gel electrophoresis. Agar is a natural product. It is a small, slow growing. Gelidium corium is a small, slow growing plant. Efforts to cultivate in tanks, ponds have been biologically successful. However, it is generally proved to be uneconomic. Gracilaria was once considered unsuitable for agar production because the gel strength was too low. In the 1950s, it was discovered that pre-treatment of the seaweed with alkali before extraction lowered the yield but gave an agar with higher gel strength. Agar has long been used to solidify media for the plant tissue culture. The type of agar or gelling agent used can influence the growth of the tissue culture. Both purity and cost of the gelling agent are important factors in any research or production operation. Phytotechnology Labs has expanded its line of gelling agents. Means this is one of the important production agency of this particular agar and its subsidiaries. So here there is a complete list of the products of agar or the gelling agents. The agar is used for general purpose. Most research and production needs are through agar only. It is used at a concentration of 6 to 12 grams per liter. Gelling temperature is about 32 to 35 degrees Celsius at pH 7 to 7.5. That means agar prefers much neutral pH. Ash content 2 to 5%. Then typical analysis resulted in the 0.3% of calcium in agar, followed by 0.1% magnesium, 0.01% potassium, 0.01% phosphorus, and 0.5% sodium. Agar bacteriological purpose or bacteriological grade agar for most microbiological work is used at 6 to 12 grams per liter concentration. Here the gelling temperature required is 32 to 39 degree and pH is 6.5 to 7.5. Ash content 3 to 7%, and here the calcium content is 0.17%, magnesium 0.09, potassium 0.80, no phosphorus, and 3.1 sodium content. Agar type A is a general purpose agar, good bacteriological grade agar used in 6 to 12 grams per liter concentration. Here also the gelling temperature is 26 to 28 degrees Celsius, pH 7.2 to 7.7, then ash content slightly more, that is 5 to 6%, calcium 0.01%, Mg 0.01, then potassium 0.1, phosphorus 0.17, and sodium 1.8%. Agar type is again for general purpose. Then others are like agar type M, then agar high gel strength. This is quite important. It is used when firmer gel is required. Here the gelling temperature is about 34 to 37, means slightly more temperature than 6.5 to 7 pH. Ash content is about 3 to 4%, calcium 0.03, absence of Mg, then 0.07% of K and 0.09% of P along with 0.72% of sodium. Purified agar has high purity and this is good for research and protoplast culture purpose. That is also used in 6 to 12 gram per liter concentration. Gelling temperature is 30 to 35 degrees Celsius and pH is 6.5 to 7. The ash content is 2%, calcium 0.02%, magnesium 0.01 along with K, then P is also in the same concentration and sodium is in 0.35%. Agarose is one more important gelling agent, a low gelling temperature agarose with excellent clarity. This is used at 6 to 10 gram per liter. Here the gelling temperature is 26 to 30 degrees Celsius, pH 7 to 8, ash content is less than 1%. Here typical calcium, magnesium, potassium, phosphorus and sodium are absent. Alginic acid is one more gelling agent. Here a polyurinuric acid which forms gels, excellent product for planting out protoplast culture or cell suspension culture. Here the temperature, pH and ash content are not given, but it has 0.17 of calcium, then 0.01 magnesium, phosphorus slightly more, potassium slightly more 2.3, no phosphorus, and 10.1 sodium content. Agar gel is a blend of agar and phytogel, offering the positive aspects of both the products. Produces a semi-clear gel. This is used at 3.5 to 5 gram per liter. The temperature preferred here is 26 to 28 degree for gelling, 7.2 to 7.7 pH, 4 to 5% of ash content, then 0.25 calcium, 0.06 magnesium, 1.70 potassium and 0.15 phosphorus. Here the sodium content is 0.45. Now there are certain questions in mind like Gelrite is very good gelling agent. Which gelling agent is best? To answer that question, Gelrite is very good gelling agent as it gives transparency to media, so one can study root growth and development by using Gelrite. Also, it requires half the quantity of usual agar as gelling agent. As you know, agar is very costly. For one bottle, it may cost more than 1000 rupees. The good quality of agar. Phytogel is an excellent gelling agent because the media is clear. In case of contamination, it is very easy to detect it. Agar-agar is best solidifying agents, being cheap, heat stable, and easy to use. Otherwise, agarose and gel-right can also be used for gelling agents. Remember, whenever the agar-agar is of low quality, activated charcoal is always used in order to remove the impurities and to keep the good color of particular gel. Now we shall see the difference between agar and agarose. Definition of agar is it's a polysaccharide extracted from red algae. Agarose is the predominant component of agar, a linear polysaccharide composed of a chain of agarobioes. Agar is extracted from red algae and seaweed such as Gracilaria and Gelidium. Agarose is a purified form of agar. Agar components are agarose and agaropectin, whereas agarose is agarobioes. Cost of agar is cheaper as compared to agarose, but agarose is more expensive than agar. Utility of agar used in solidifying agents in microbiological culture media, in the food industry for making jellies, ice creams, and other culinary dishes. Agarose is usually used in gel electrophoresis. So we were discussing about agar and agarose. Along with that, we will also see some of the difference between agarose and polyacrylamide. As you know, agarose is used in gel electrophoresis and polyacrylamide is used in PAGE, that is for the detection of minute differences existing between the proteins or amino acids. Composition of agarose is it's a complex sugar or polysaccharide derived from seaweed. Agarose gels are made of long chains of interlinking sugars to create a meshwork like a spider web, whereas polyacrylamide is made by digesting acrylonitrile with nitrile hydratase. Polyacrylamide is made by the chemical cross-linking of acrylamide and bisacrylamide. This linking produces a molecular sieve. Configuration of agarose is horizontal. The gel will be flat on the table, whereas polyacrylamide is vertically lean. Gel is standing on the table. Casting methodology of agarose, it sets as it cools. Agarose comes in powder that is mixed with buffer and then microwaved. This is poured into the gel frame and allowed to set. Polyacrylamide is set by chemical reaction once cross-linking occurs. Coming to the properties of agarose, the higher the agarose concentration, smaller the pore size. Typically, concentration used is 0.5 to 2%. For best results, 4% agarose is used in order to get the clear-cut bands after running the gel electrophoresis, whereas polyacrylamide, the porosity is dictated by the ratio of acrylamide to bisacrylamide. Usually, resolving gels are made at concentration 6 to 15%. Utility of agarose: DNA fragments of 50 to 20,000 BP in size. Resolution of over 6 MB is possible with pulse field gel electrophoresis, whereas polyacrylamide gels have very high resolving power for small, that is 5 to 500 BP fragments of DNA. This is good for analyzing single stranded DNA. The utility or pros of this one, what is that? Agarose, it is easily made, poured and handled because gel setting is a physical rather than chemical agent. Here the gel sets quickly up to say 30 to 60 minutes. Simpler, easy recovered from the gel. Gels can be refrigerated in a plastic bag or film. The gel is non-toxic, or so it is easy to handle. Pore size can be manipulated to increase or decrease the molecular sieving. Different buffers can be used to alter the resolution and runtime. A large range of size of DNA can be separated. Whereas in case of polyacrylamide, it may give more reproducible results as it is chemically synthesized and therefore may be more consistent between batches. Here the pores are of uniform size, can't be decreased or increased, non-reactive with samples since there is no change associated with it. Thin gels can be cast, which can promote better separations of higher field strength due to efficient heat dissipation. Pore size can be manipulated to increase or decrease molecular sieving. Different buffers can be used to manipulate resolving and runtime. very high resolution power is obtained in polyacrylamide. The disadvantages or cons of agarose is agarose gel do not have a uniform pore size. Low percent gels are weak and may break when lifted. High concentration gels are often brittle and may not set evenly. The disadvantages of acrylamide is a potent neurotoxin. Disposable gloves must be used when handling solutions of acrylamide and mask weighing out powder. Once set, polyacrylamide is considered to be non-toxic, but polyacrylamide gel should also be handled with gloves due to the possible presence of free acrylamide. When Ethereum bromide is used as a stain, more care should be taken. More care needed when pouring the gel on to ensure the gas bubbles are removed. Longer wait time for gel set as compared to the agarose gel slab or gel electrophoresis. In gel electrophoresis also we use ethidium bromide, but nowadays there are different substitutes for this what is that ethidium bromide, but that is rarely possible in case of page. Thank you, friends. I hope so far I provided the information about different gelling agents like agar, gel rat, then agarose and gelatin. If you have any doubt, you can put it in the comment box. Thanks for watching.